everybody. All right, so what are we doing today? So before we get started on Rust, I wanted to take a little detour and talk about GitHub. What I have done is I've taken all of the projects, and you'll notice that whenever any of the projects get created, it creates a Git file and the kind of the Git stuff around it as part of the project directory. You can see the .git file and that sort of thing. Anyway, so what I've done is I've uploaded all of those as separate repositories, because that's how they're structured, to github.com/ricklearnsrust. The one I did last week, I haven't uploaded yet. So I thought I would point out some of the things I've done here. So if you look at the repositories, you can see there's tuples, print list, all those guys. This one is a special one that is kind of an introductory page to the whole thing. And the one I wanted to point out was notes. And the reason I want to point that out is because I'm going to be putting little notes to myself in here for behaviors that I don't going to do very often, and they're multi-step, and I want to remember what I did. Okay, so this thing is about how to, if you wanted to do your own, if you're following along and you're creating your own repositories, that you would upload yours also to GitHub. So first thing is you need to create a secure connection between your computer and GitHub after you've created an account. So first create a GitHub account, then you need to create a secure connection. And there's some explanations here. It's another multi-step procedure that they've already explained, so I don't need to. And then there's a prerequisite number 2, and you should do that at least. Okay, so now, assuming you've done all of that, then there's these steps that are required to get the whole thing to work properly. All right, so let me just pop up here. And what I'm going to do is I'm going to navigate change directory C:/Rust. Okay, and the one that I created last time, it's called structures. So change directory. Structures. That was control space, by the way, that did the completion for me. Okay, so now that I'm in here, so that's that. But here, now it says, in GitHub, select your repositories from the user menu, click New, click Enter, select a license. I select MIT, and then click Create Repository button. Okay, so let's do that. So, where are we going? Oh, your repositories, up here. Your repositories, we were there before, but that's the fastest way. New. This is going to be structures. I'm going to leave that open. I'm going to let it be public. I want to select the MIT license. MIT license is pretty forgiving, flexible. Everybody can use your code to do whatever they want with it. That's fine. Create repository. All right, so there we go. Okay, so let's go back. So there's the repository. It's called structures. And we're going to go back to here. Okay. So there we go. Create repository button. Okay, we did. Now, on locally. So I need to go here. So let me get this. Where to go? This one. I'm going to get this back. Okay, here. So here, I just have to say git add dot. So that adds the files to the repository. Git commit, and you must put in a message first commit. You don't have to say first commit, but you have to provide a message what you're doing. Okay, so there's now committed, And now git remote add origin. Holy cow. Git at github.com colon. I should have learns Rust. I should have copy pasted this / structures. So it says repository name. So we're going to use structures.git. Okay. And then this. Now, the reason for this git branch -m main, which I think I did, or did I skip it? Oh, I think I skipped it. Yeah. Git branch -m main. There we go. Okay. I missed the line. Anyway, so this one, the git add adds the files. This one commits them. This one, so the old standard was to create a master branch. About 1.5 years ago, there was some kind of controversy over the use of the word master, and GitHub decided that they were going to change the name of their main branch to main, which kind of makes sense, right? Now, but the thing is that this tool that we were using, Cargo, is still creating master branches. So this line changes it to be more in line with the GitHub standard. And then once you've changed the name, it doesn't matter. And then we did the create that relationship, and now we actually need to do the push. This is what actually takes the code from your computer and puts it up on GitHub. So push -u -f origin main. And the reason we had to do the change of main is we need to say which branch we want to push. So I changed the name of the branch to main, and now I'm pushing the main branch, branch named main. Okay, and there we go. So we've got some stuff. You can read that if you want, and that's basically that. Now, this part here is kind of optional, but not terribly. If you're going to make public repositories, probably a good idea to do. So what do we want to do? Again, we want to go to the repository. So repositories, where are you? So here I just go there, and repositories, and structures, and we want to go to settings, and then code security, I think. No. Branches. Now, so the default branch is main, and then we want to add a branch protection rule, and you will need to type main here. So when I first did this, I thought this meant I wanted to give the pattern a name so I could reuse the pattern across multiple branches. But no, this actually wants the name of the branch. And you can enter a pattern, which means you can say M star and say, okay, every branch that starts with the letter M, this is a rule that's going to apply. And we're going to say, require a pull request before merging. And I'm going to require review from the code owners. So a pull request means that instead of somebody being able to commit directly into the main branch, they're going to have to create another branch. They're going to have to make their changes in that other branch and then generate what's called a pull request to say, please allow this code to be merged into main. And what I'm going to say here is that we need to have at least one approval, and we need the code owner, me, to be able to review it and approve it before it can go in. So public, it's kind of a safety thing when you've got public repositories. You really don't want people bashing and smashing on your repositories. Not that anybody's actually going to do that, but whatever. So create. And, oh, really? I have to, what's my password? Oh, darn. Did it just, oh, that's not my password. Oh, okay. Huh. What's my password? All right. Well, that wasn't my password, so it doesn't matter that I've shown that. LastPass. What? That was really dumb. All right. I'm gonna slide this over here for a second. I really don't need to be broadcasting this. That one. Confirm. Okay, that did it. I guess after this, I'm gonna go change passwords. Okay, so it's back. It's done the thing. Yeah, you cannot do that. Okay. So there I've got a branch protection rule on main. That's the commit. All right, so that is done. We put this away. All right, and what's this? What is this stuff? Go away. All right. So let's start with, here we go. So this is where we were. Enums. All right. So let's have a look. The enum keyword allows the creation of a type which may be one of the few different variants. Any variant which is valid as a struct is also valid as an enum. Ooh. Well, enums are fun because they're way more flexible and energetic than like enums in every other language I'm familiar with. Okay, an enum may be either unit-like, right? Page load, page unload, right? Those non-dimensional objects, which is, I guess, probably what I'm most familiar with enums, or like tuple structs. Ooh, this is different. Key press char, paste stir, or select structures. Click. Whoa. So what makes these different? So that's a single enum. Create an enum to classify a web event. Note how both names and type information together specify the variant. Page load not equal page unload, and key press char not equal paste string. Each is different and independent. Interesting. Okay. So why would you use, like, why do you have these? Because couldn't you just create a struct that did this? Maybe, maybe not. Anyway, all right, let's see how you use them. A function which takes a web event, enum, is an argument and returns nothing. So inspect event, web event. Okay, so web event and match event. Oh, okay. So one of these things is going to happen. Oh, I get it. Okay, so it's not all of these things. One of these things is going to happen. So it's either a page load or a page unload or a key press or a paste or a click. And depending on what happens, you get more or less information. Because this returns nothing, this gives you nothing, this gives you a char string, and the click gives you an X and Y coordinate. Okay, very interesting. Very interesting. Okay, let pressed equal web event key press X. To owned creates an owned string from a string slice. To owned. My text to owned. That's pasted. Click, load, unload. Inspect. Okay. All right. Fun. All right, so that's a very flexible enum. So basically it's like a list of possible event things that could have occurred, and you're going to populate one of them, and then you can say, hey, based on which one actually occurred, let me do something. Okay, well that's cool. Okay, yeah, that's cool. It kind of groups things together. Because if in other languages, like in Java or C# or JavaScript, to do this, you'd end up with this event type, and then a switch saying, okay, if the event is event type whatever, then you've got some parameters, and in JavaScript you're flexible because you can shove anything else into that object. In C# you'd have to define, or in Java you'd have to define all the different potential things that it could be. So maybe you do like a base class and then extend it with the different parameters depending on what kind it was. So you'd have like a web event base class, and then you'd have a page load event that inherits from web event, and etc. etc. So but that's a lot of verbiage to get to the same spot. So that's cool. Okay. Yeah, I like that. Okay, what have you got here? Type aliases. If you use a type alias, you can refer to each enum variant via its alias. This might be useful if the enum's name is too long or too generic, or if you want to remove it. Rename it. We can refer to each variant by its alias. Operations : add. What's operations? What? Oh, there. Type operations equals, there we go. There's the operations thing. So I can create an alias. Some really long name, make it a shorter name. Well, why did we define a really long name in the first place? Or maybe it's some other library that decided to make it a really long name, and we know which thing we're talking about, so we'll call it a shorter name, I suppose. Okay. The self alias. Oh. Self. Oh, that's what that self is. Okay. The most common place you'll see this is in impl blocks using the self alias. So enum, very long things to do with numbers, add, subtract, self, add, self. Okay, all right, interesting. Okay, read stabilization. Yeah, whatever. Okay, so a couple of things that we learned. Still no code written. This is kind of boring. In that we have, yeah, not a whole lot of anything going on here. All right, moving on. 3.1.1, use. The use declaration can be used so manual scoping isn't needed. Use. Okay, what's going on here? Oh, okay, all right. So instead of having to say status : poor, by using the use statement, we just say poor. And the star brings us everybody. I'm never going to remember this. We'll have to bump into it later. But crate status, yeah, it's not something I'm going to remember. So we'll eventually bump into this, but not right now. And then whatever. Okay, so that's interesting. We'll have to revisit that one when we get tired of typing too much stuff. Actually, I wonder whether it's going to suggest that we use a use. We'll have to find out. Actually, let's do that. We'll copy this back to here. All right. Close close folder. Okay. Terminal. Terminal. Change it to C:/rest. All right. Cargo new enum. The name enum cannot be used as a package name, as is a Rust keyword. Okay. Interesting. That's a good warning. Cargo error. New. Enum alias. How's that? Okay. So let's file, open folder, Rust, enum alias, select. All right, there's the git ignore that I was talking about before. So that's when we know we've got a git thing going on here. The other thing, by the way, let's just pop this over here. If we look inside enum alias, see there's the .git directory. This contains your local repository. So anytime you add and commit and make changes, your changes are and a bunch of administrative information is stored in here, and then it's uploaded. The git ignore basically says these are the file names, file types, directories that you do not want to commit. So for instance, if you're doing JavaScript, you would use git ignore to say, hey, that whole node folder and all its subfolders, don't send that to the repository, because that's generally you want to send source code to the repository and artifacts that you cannot generate from building. Okay, let's put that away. All right, so anyway, so there's main. Let's, paste. Okay, now the thing I was wondering about was if I said status : poor, is it going to suggest? No, it's not. And even if I have it already here, it still won't suggest. Interesting. And if I comment this out, will it suggest? Said, hey, you could. What's the light bulb? Oh, well, it's going to ask me to. Okay, no, I don't want to replace that. Thanks very much. Nope, won't do it. And if I do this, that's, unknown. So save that. Error. Right. There it is. There it is. Consider importing this unit variant. Use great status poor. Now, so no quick fixes available. So it's unfortunately not going to, you can't just click this and have it do it for you. But we finally get the suggestion. We had to just type the word poor and then go, oh yeah, and you can do this. Okay, so that's cool. That means that I will actually remember this, because when I go to use it without writing this, it's going to suggest that I do it. All right, so that's great. So as long as the suggestion is there, it'll kind of prompt me and go, all right, I remember that. All right, so let's, yeah, there really isn't much else to do here. But we'll run it just to make sure. Let's just run this thing once. The poor have no money. Well, civilians work. Okay, so the match status poor. The poor have no money. So if I change this to rich, and I change this to, oh, look at that, civilian soldier. And then it suggests a whole bunch of nonsense. Soldier. Okay. So let's save that, and let's run it one more time. All right, the rich have lots of money, soldiers fight. All right, perfect. Well, commentary on society aside, the code works. Note the lack of scoping because the explicit, yeah, right, because we didn't have to say, because we would have had to do it here too, status colon rich, right? Which we could still do, but it's interesting. If I do status colon rich, it's not going to suggest that, you know, you could use the use instead. But if I use this approach without it, then it's going to suggest that, hey, to fix this, do the use. It doesn't suggest status colon. Interesting. Actually, it probably should suggest both of those options, and then you get to pick one. But I guess we're not quite that sophisticated quite yet. Oh, and by the way, the whole thing I did on the command line with the add and all that stuff, it is possible to do it here. So, for instance, here, there's 4 pending changes. These are, now, I had to do add git space add space dot, because I needed to say, okay, add these files. What this is doing is it's saying, well, these are uncommitted files. Obviously, they're in the project, you want to commit them. And so it will do that add and the commit step all at once. But like I said, you need to have a message. So we'll go first commit here, and we'll click commit. And now these things, it's in there. So that typing the message in and that was the equivalent of the add and the commit commands. Now you can also push from here. Push branch. We can rename the branch. So we'll just call that main. And we can, well, we still can't push, because the one thing we cannot do yet is push to GitHub, because there is no repository in GitHub to push to. And we haven't done that linkage. And I don't think there's, add remote. I think. Provide a repository or pick a repository source. Add remote from GitHub. Ooh, interesting. Interesting. So I'm going to try that. But I need to create the remote on GitHub first before we can do that. Anyway, but you can do all of that stuff I did on the command line. You can do it up here with click and whatever. But geez, I kind of like the script approach, because rather than having to take screenshots and say, okay, click this, click that, click that, click that, I can just give you a list of commands and you just type them in. And then you can also script it. So, I mean, I did all those commands manually, but you could create a little script file that you can play back. At least on... well, you mean with Linux you can do it. With Windows you can create a PowerShell script, and you can pass parameters to the PowerShell script and have it do things too. So anyway, all right. Sorry, kind of wandered off there. But anyway, okay, so let's escape that. All right, and we will, what did we do? Not much. All right, but we're done. Okay, so let's move on. All right, so that's the use. I should have called that use instead of aliasing. Enum aliasing, elim use. Okay, fine. So this is, by the way, just as an aside, I guess, this is what I expect from enums, this kind of behavior. This, where you have a list of things. And the other thing to notice, I noticed it out of the corner of my eye. Let me go back, because I thought that was interesting. Where are you there? Is that, see, soldier equals 1, rich equals 0, poor equals 1. So this is very similar to how C#, JavaScript, Java. No, JavaScript doesn't have enums. TypeScript. TypeScript's enums are different again. Java and C#. So what Java and actually, yeah, so it's a zero-based thing, and you just name these things, 0, 1, and it assigns numbers to them. So internally it represents it as a number, but in your code you can refer to it by name. So for instance, if you were creating a rock, paper, scissors game, then you don't actually care whether rock is 0, rock is 1, or rock is 2. You just need 3 different values to represent rock, paper, and scissors. And lizard Spock would be 4 and 5, or 3 and 4 if you'd like. And it's 0 based, right? So then you can, but it's things, so you use enums for things where you want to name them, but you don't really care what the value is. Like rock, paper, scissors, lizard, Spock. It's like, there's just 5 things, and you're comparing, did we both have lizard? Did we both have rock? And, and then you've got some rules for this beats that beats that beats that. Or, Celsius, Fahrenheit. If you're saying, okay, I want to do a Celsius versus Fahrenheit thing, then I say, is it Celsius? Is it Fahrenheit? And I don't really care if Celsius is 0 and Fahrenheit's 1 or the other way around. It's just one of them, I have distinct values. I don't really care what they are. I just need distinct values for the different things I'm keeping track of. So that's where you use enums. Because your code's a lot easier to read. Because if I was down here and I had match status 0, 1, the rich have lots of money, you go, why is 0 rich and why is poor 1? And actually I got that backwards. So it would, when you're reading your code, it makes it a lot harder to understand for somebody else to understand and for you to also understand. Now, the thing is, when you're writing the code, you understand, but you have to think about 6 months from now, right? So that you will hate you, current you, if you don't use enums, because it makes the code harder to understand. And so will everybody else who's now reading your code will go, what the heck is going on here? Why is he comparing against 0 and 1? But comparing against rich and poor, civilian and soldier, that makes way more sense. Okay, so rant over. Back to here. So let's look at C-like. Okay, what do we got here? Enum with implicit discriminator. What the heck? Oh, right. I know it, because I think what we just talked about. So that will be assigned the value 0. That will be assigned the value 1. That will be assigned the value 2. But it looks like we can also, which is again something you can do in C#, you can assign values to the different elements of the enum. This is what basically happens in TypeScript. When you create an enum in TypeScript, you can assign values to it. And then, this is like number 0 as I32, and then you can, as I32, roses are color red as I32, shown in hex. Okay. All right. Again, nothing really too spectacular here, but that's basically, so this as thing is, we haven't used that before. I tried to use it when I got stuck on that loop, right, trying to do the conversion, but you know, no big deal. But it didn't work because what I was trying to convert it into was smaller than the value, so I had to do that try stuff. Okay, test case. Are we going to get to some real code here? Okay, what have we got? A common way to implement a linked list is via enums. Really? Okay. So, anybody who is not written C or C++ code before probably doesn't know what a linked list is. Because really, you know, if you're doing C# code, then, you know, you create a list. And in that list, you stick as many things as you want, and the list is infinitely expanding. And I guess in Java it would be like a vector, and you can just shove more and more stuff into it, and it's all cool. Most of the previous languages, like C and C++, I don't know about C++ so much. I haven't written that in a while. But when I had to do it, it was always creating your own list implementation. If you needed to create a list of things that was, you know, expandable and contractible, then what you needed to do was create an element and have it provide a link to the next element. And if you needed to go looking for something in that list later, you would march down using the links, march down the list to the next element, till you got to the end. And then there you would, you know, so you would find the element you were looking for and remove it. And you could remove it by basically the node, the previous node points to the current node, and the current node points to the next node. And if you take the next node pointer and you set it to the previous node's next, then that effectively takes the current element out of the list. And then there's doubly linked lists, which point forwards and backwards. And the reason you would do that is so that it's easy to find things, because if you have a singly linked list, like you can only go in one direction. If you get somewhere that you know, that thing, and now you need to go back, you need to go back to the beginning and do it again. A doubly linked list allows you to traverse up and down the list from anywhere. You can, you know, move your way up and down, which is convenient in some cases. Also means that your bookkeeping is much more complicated, because now you have forward and backward links to worry about when you're adding and removing elements. All right, anyway, so that's enough of that. Let's see what they're doing here. So they've created a, what's this? Use create list. All right, so they've got this thing. There's a crate called list, and we're going to bring all of its elements in. And then we're going to call an enum list. Isn't that kind of dangerous to call the enum list and have a crate that's also called list? Anyway, all right, whatever. I guess I'll live with that for now. Okay, so cons, tuple struct that wraps... Cons is a tuple struct that wraps an element and a pointer to the next node. Okay, so we've got U32, which is the value. So I guess it's a list, a linked list of integers, U32 integers, right? Yeah, so I mean, that could be more complicated. Obviously, that U32 doesn't have to be a U32. It could be some quite complicated object. But the point is that you've got this object and then this other thing, which is the pointer. And it's box list. And so box has some kind of meaning. I assume, because you can talk about boxing and unboxing. So is a piece of data, and I assume that's something to do with it, but unclear what the meaning of that is for now. Okay, and then nil, a node that signifies the end of the linked list. Okay, so we have cons. Now, cons was not defined anywhere, so is it part of crate list cons? And is it crate list box? Well, we'll find out. And then methods can be attached to an enum. Okay, so this impl thing, what we did with the printfs, I guess we can do here as well. In other languages, where we can define public and private methods or functions that attach to objects. So I guess this is a similar kind of thing. Okay, and what have we got here? We've got a lot of methods. We've got create an empty list. Okay, new list nil. Okay, so I presume that's nil because this is saying this enum could be either this thing or this thing. Right, I have to keep remembering that. The list that the enum says that or that, not both. Okay, so we've got it's either nil or it's that. Okay. New, that's new. Oh, no, that is, all right, no, it's not. No, I'm misinterpreting that. That is a method called new that returns a list. Okay, that's pretty simple. Prepend. Consume a list and return the same list with a new element at its front. Okay, so prepend self element u32. So we're going to provide a u32 and we're saying, hey, our data type, and hey, here's a list, or actually self. So the self means then that okay, interesting. So self is me because I'm implementing list. So I'm gonna say myself dot prepend a number, and it's going to return back a list, and that list is going to be cons, the new element, and then box new self. Now that's different. I don't know what this means exactly. Box new self. So I'm taking self and I'm box. So it's attaching. All right, I guess. Yeah, okay, well, maybe we'll learn some more a little later. Let's move the rest of the way through and see if we can figure this out. Return the length of the list. Self has to be matched because the behavior of this method depends on the variant of self. Self has type %list and star self has type list. Matching on a concrete type T is preferred over a match on a reference %T. After Rust 2018, you can use self here and tail with no ref below as we rest as well. Rust will infer %s and ref tail. So, sorry, this is like all over my head. I don't know what you're trying to tell me here. Match self, star self, can't take ownership of the tail because self is borrowed. Instead, take a reference to the tail. Const underscore ref tail 1 plus tail length. What? Oh, I guess. So, what? So self is the list. Self is star self has type list. Okay, so if this is a list, then if it's this, if it's one of these, then it's going to have this box list attached to it. And this box list attached to it is going to be one less than the total length, because this does not include this element. That's weird. Okay. All right, so what's happening is every element has the rest of the list, but that means that every time I attach something, so I have a first one, okay, and it's got a nil list attached to it. Then I attach the second one, and the second one has two things attached to it. Well, yeah, the third one, sorry. The third one will have two things attached to it plus me. And then I am going to be boxed inside the fourth guy, and I'm going to hold three elements. The guy who holds me is going to have four elements, but it's a kind of a weird, like it's a, so if I hold four, then the guy that I'm holding, he holds three, and the guy that he's holding holds two, the guy that he's holding holds one, and the guy that he's holding, well, that's the null. And the one that he holds is the null. Wait a minute, if he holds the null, then why do I have to add one? Because do I really want to count null? Because that's just marker of the end of the list, not an actual list element. All right, so we're gonna have to try this. All right, let's look, and then nil, 0, right? So you're telling me that if there is nothing, it's 0, length of 0. So what's the +1? Why +1? Because you would think that the nil, all right. Well, maybe, I don't know. Anyway. Okay, return representation of the string as a heap allocated string. Stringify. So, is this recursive? Is this recursive? Is this what's going on here? Because this is going tail.stringify. Is this length? Oh, yeah. This is recursive. Length. So this is calling, oh, okay. So this is calling length. And it's saying, hey, how long are you? And then it comes in here and it goes, oh yeah, I've got things attached to me. How long are you? And then everybody reports back a length +1? So, all right, so it goes, how long are you, how long are you, how long are you? So then the lowest end guy, instead of calling this, there is, because there's it'll report 0 because he's got the nil. And then the next guy up will receive that and go 0 plus 1. And then the next guy up will receive 2. Or we do have to set a breakpoint here. We need to watch this recursive thing happening, because this is also recursive here, right? Stringify is calling stringify, and so we are going to output everything else. Format is similar to print, but returns a heap allocated string instead of printing to the console. Okay, nil is nil. Format. Cool. And then we've got main, prepend 1, 2, 3. Then linked list has length. Okay, all right, cool. So let's do this linked list thing here. Copy this. All right. So enum alias. All right, so we're gonna close this. Close folder. Terminal. New terminal. Okay. And then open folder. Rust. Linked list. Oh, and one other thing I wanted to mention. You probably have noticed I've got the little green circles here. Shout out to Tortoise Git, my favorite Windows-based visual Git manipulation thing. You gotta love this thing. Anyway, well done, guys. All right, so let me just where are we? Linked list. Let's take folder. All right, here we go. Source main. Just like that. Paste. Okay. Save that. And let's run just to see what happens. Yeah, linked list has length 3, 3, 2, 1, nil. We are prepending. So when it goes prepend 1, so it's putting 1 on the list, then prepend 2 puts that in front. Prepend 3 puts that in front. Okay. So, yep. All right, let's have a look. So what we wanted to do, all right, what I wanted to do is I want to set a breakpoint here. I want to see how it deals with this. I want to see, actually not there. Let's just set it on the match. Okay, and we'll do a debug. Debug, run and debug. Right, yes, I don't have. Would you like to? Yes. Yeah, you can close that, thanks. Okay. So what's going on here? We're here, self is tag 0. No, just, right, so we're length and then stringify. Okay. All right, so self is tag 0 and then tail is this monster. Okay, so let's just step F10. Okay, and so we've got tail invalid address and tail dot length, so step, and we're back to that breakpoint again because now we're like one more level deep. Let's see, call stack. So yeah, let's look at this. So we were here. Let's do it one more time. Are we? Oh, I see. We're paused in the breakpoint here. Can we tell anything from this? Let's see, how do I interpret this? Okay. That's not telling me anything, I don't think. Alright. So step back to there again. Alright, and where are we? Do we have... No, we still only have 4. So I'm not really getting the sense of recursion here because the call stack is not getting deeper. So I don't think I'm recursing really. What's going on here? Oh, and there we have a nil. Okay. But we did end up calling length all those times. We just don't... TID. Is it all within the same... Oh! I didn't know I could do this. Ah, look at that. Actual assembly language. Cool. And it's x86 assembly language too. Okay. Oh, the stack. So can we go poke around with the stack? Range was there. Okay. Alright. Back to the code. And then yeah, we can executing those lines. Returning from those lines. Like 3. All right. Can we? Let's do this one. Maybe this will be easy. The string will be easier to figure out. Oh, hey, I set breakpoint for the string. Oh, why? Oh, because oh, shoot. Continue. Okay, so there we're stringifying. Yeah, I started running again. I think I've got two. I got 2 copies running now. Okay. Okay, so it's right. Where's the terminal? Oh, the wrong terminal. Oh, there it is. 3210. All right. That's not helping because it's hard to see what's going on because we have no place where we can go look. So tail.stringify is stringifying the rest. What I don't understand is if tail.stringify is stringifying the tail, then why isn't it doing like 3 32, 321, 321 nil. Like, why isn't it doing that? Because the way I've got the mental map of this I've got says that tail should be everything else. But maybe that my mental model is wrong here. Because it seems like... Because it's calling tail.stringify, which is calling itself. Which says, okay, let me go and stringify this. Which says, oh no, it's one of these. So let me call itself again. And then, but you don't actually do an actual string until, oh, but head, what's head? Head is the U32. Oh, okay, now I get it. What's going on here? Okay. So we're formatting, in the format, we are saying, write the head, and then write everything else. And then this thing says, oh, we need to do another format. We need to do another call of stringify. And stringify says, okay, what's this new head, the next guy's head, and then what's the rest? So then he says, oh, okay, my thing is, so we end up with the second format being invoked inside this curly bracket. Inside the second curly bracket, we're actually invoking the whole thing. So in fact, it probably, like if we were to write it out, it really does look like that. It's like curly bracket, comma, curly bracket. And then inside here, it's curly bracket, comma, curly bracket. And then until we get to a nil. And then it actually writes nil, and then it writes the head and the head and the head. Right? So I think that's actually what's going on. It's like it's nesting these. So it is recursive. It's just that I was misinterpreting what was going here. Right, so the head, okay, all right, so it's saying here, put the head here, and then put the rest here. But the rest is another call to stringify. And stringify returns a string that is the rest. But it figures that out by saying, okay, what's the head and what's the rest? And the rest is more stuff, which then calls stringify again and then finds the rest. And then the last guy says, let me call stringify again, and it returns nil. And then that's the end because it doesn't call stringify anymore. So then it returns from stringify, returns from stringify, returns from stringify, and you get the string. And that's why when you watch the breakpoints being invoked, you see it hits this 4 times, and then it hits this 4 times, or 3 times, and then this once, and then it returns because it's returning from this and with that information. Okay, so that explains the stringify. So a similar kind of thing is happening here. So tail.length is, again though, so in this particular case, tail.length is 1 plus, let's call tail.length. And then tail.length returns 1 plus, let's call tail.length. And so it's 1 plus 1 plus 1 plus 0. So eventually it gets to nil, which is 0. And so it's 1 plus 1 plus 1 plus 0. That's what ends up happening. So tail.length does not give me the length of everything. It just gives me 1. And then it calls tail.length, which gives me 1 or 0. So this thing is either we're going to return me 1 or 0, or multiple. Each of those is going to return me a 1 or a 0. And depending on how many times it calls them, it's going to add them up, and we're going to end up with however the length is. Okay, so that is recursion. So we are doing recursion here. Yay, team. All right, so that makes sense. Got it. Okay, let's go see what. Okay, let's go see what, if anything. Oh, let's save this. Let's go see what, if anything, we're supposed to do here. Are there any activities with this? No activities. Okay, so you know what we're gonna do. So I'm not gonna start it now because it's like over an hour. But next time, I am going to attempt to append, add stuff to the end of the list, because this kind of took the easy way out, I think, because it said, okay, just let's stick everything to the beginning, because then you could just say, let's take the whole list and stick it on the end. I want to do something different. I would like to insert. I'd like to do some real linked list stuff. I want to insert stuff. I want to append. So add it to either end of the list, and I want to be able to insert it and remove things. So let's do some fun stuff with linked lists. But that'll wait till next time. All right, that's it. I'll talk to you guys next week. Bye.